How do we always end up in the same dreams together?
How do you know I'm not just a representation of your brother created by subconscious? Should we be more worried about which of the number devil schemes we've fallen into this time?
Nobody likes a war word, Claude. Now come on. Teplotaxel is probably waiting for us.
But where?
What did I just say,
Well, thank you, kind sirs. So much for that. Now I've got a lesson to teach, so if you wouldn't mind.
No, I'm telling you that there has to be some reason why we look so blocky.
Yeah, he'll probably try to fit us into triangular and circular slots like that game for babies and then tell us we don't fit because mathematics said we weren't allowed.
Very funny, except for the fact that math can't tell us what to do. It's just a theory.
And you missed my whole point.
Ah!
Well, now you have no right to insult Maude. She was correct indeed.
Jeez, you scared the devils out of me.
Well, that's strange. I didn't see any of my brothers or sisters.
So I can't wait to hear what we're doing today. Is it hopping, or could it be prima donnas? Or dare I say it, Bonacci's?
Haha, you are what makes mathematics fun. No, but it'll be a combination of all those things. Or should I say, all of those things can have a little bit to do with what we are learning.
Oh, brother, here we go.
Hush up, fatty. Yes, today we are learning about sequences.
Well, what's a sequence?
Come over here and I'll show you.
Hey, this isn't anything special. It looks like you're just counting with blocks.
Yes, well done, Claude. It looks like you have indeed passed the preschool education standards. But what can you tell me about the numbers when referencing the previous or next number?
Well, I guess you could say that the second row is just the first row plus another block, and that the third row is the second row plus a block.
So you're saying that the difference between the rows, in this case, is one block, correct?
Yeah, I guess if you wanted to get confusing about it.
But this doesn't have anything to do with hopping or any of that other stuff. Like you said, this is just preschool stuff.
Ah, well, you just learned the concepts of arithmetic sequences. You find the difference and add it to the previous row. Now can you tell me if the first block was the first row, then how many blocks would be in the 35th row? And using that, how many blocks were in the 36th row?
35 and 36, durr. If I knew it was going to be this easy, I wouldn't have even bothered to fall asleep tonight.
It's easy to figure a recursive and explicit row when the difference is 1, isn't that right? But you just proved that you can figure out the exact number in a sequence by knowing the difference and the first row. You also used the number previous to the row you were trying to find the next row. Explicit and recursive, simple as that in an arithmetic sequence.
Hey, you're ignoring me. I get that redo what's it and the explosion or whatever, but you said that hopping is a sequence too. And as far as I can tell, if you hop the number from number 2 from 1 to 4, the number that adds up to make the next one doesn't equal the row after that.
Yes. I rather like that. I think I'll call them redos and explosions. Because an explosion happens right there, correct? Right amidst the action, and you have to redo the previous row to get the next one. Okay, to answer your question, Maude, hopping numbers of 2s are sequence, just not arithmetic sequences.
But then, I don't get it. What else is there?
What else is there in basic mathematics when you can't add or subtract anymore?
Multiplication! We're just talking about it right now, and it's really boring.
That's where you're wrong, Claude. Multiplication is simply delightful. And you are also correct, it is just what we need. So Maude, what can you tell me about the relationship between the first row 2 and the second row 2 hop 2, keeping multiplication in mind?
Well, if you multiply the second row by 2, you get 4.
And the third row to the fourth?
2 times 4 is 8. Ha, I win.
There is no winning in mathematics.
Ow.
But you are correct. Now, you can see using the redo method that every row is just the previous row multiplied by 2, isn't that right?
So this type of sequence is just a hopping number in disguise?
Precisely. Geometric sequences can be exact copies of hopping numbers.
But wait, Before you could explode directly to the number you wanted in the arithmetic sequence. You can't do it in this one.
Can't isn't a part of mathematicians' vocabulary. Obviously, you wouldn't know that. You can not only explode to the number you want, but once you are able to do it, once you can explode to any number you want to. All you need is the beginning row of the sequence and the rate at which it explodes.
I still don't get how you could explode to whichever number you wanted. I have the beginning of my sequence, 1, and the rate at which it explodes, 2, and I want to find the 5th number in the sequence.
You should be able to find this easily. Remember, these are hopping numbers. So just take 2 and multiply it by 2 hop 4, correct? That would be 2 hop 5. You can easily tell that 2 hop 5 is the same as 2 times the rate hop 5. And it works with all numbers, even if they aren't hopping numbers, so long as the rate is equal every time.
Well, what happens if the rate isn't the same, and it doesn't have a difference like the prima donna numbers?
I did say that there was a sequence for prima donnas, but I hardly think I can remember it. It does have around 14 stables.
Stables?
Oh, you know, for housing any kind of number?
Hey, they call those variables at school.
Well, I think stable is a more fitting name. You can't really have any number staying in an uncomfortable place like variables. Stables, on the other hand, are much more comfortable.
Is there anything we can do after figuring out a sequence?
Of course, my dear. There is no end to mathematics. We have only discussed half of what I need to tell you.
Oh, jeez. Can we hurry this up then? I have a math quiz in the morning. I don't want to be too tired.
You're already asleep, though.
Anyways, a series is just any sequence added up.
But how do you decide that? Like, how would you decide which numbers to add up and how many of them you want to add?
That's up to the mathematician.
Okay, say I wanted to add up these first 5 rows here. It wouldn't be the same if my sister wanted to add up her sequence over there.
That is correct. The sequence you are pointing to is the arithmetic one, correct? And your sister's rows are geometrically sequential. So a universal way to add each type of sequence was generated by a very logical mathematician. He said in any arithmetic sequence, the difference will be determined by adding the starting row and the finishing row, but then also multiplying it by half of the numbers it took to arrive at the finishing row from the starting row.
Okay, now my head's starting to hurt.
Let me explain. If you have the starting row and the finishing row, you should know all the rows in between and the amount of rows in between because you also know the difference.
Okay, I guess that makes sense. But why take half of the finishing and starting rows added together?
Look at it this way. If you just take the first row and the second row and find the series sum, the finishing and starting rows add up to 3, which is also the sum of the series. But since there are 2 terms, you would multiply it by 2, throwing off your calculation.
Ah! This is too much math. I'd rather be frolicking with a chocolate mousse in a waffle graveyard than doing this.
Something tells me you need to eat more before bed.
Well then, how do you add up geometric sequences?
I'm afraid geometric sequences are quite a bit more complex to explain, but there is this formula.
Wow, how did I not see that before?
Like, before you need to know how many rows you're adding up, you need to know the first row's value and you need to know the rate at which they go up. I'm sorry I can't explain it well, but I'm afraid an algebra student might not understand at this level.
Well, I wouldn't say that's very helpful, but I guess it's good to know.
Oh yes, I almost forgot. Zeno's pair of socks is a special theorem to explain a certain type of geometric series.
Is there another formula like that one?
No, my dear, it can be explained easily. First you take the row that you start with, your geometric sequence, and find the rate at which the sequence will increase.
Sounds like a geometric sequence to me.
The difference is that you must find out if the sequence will go covert or whether it will increase to infinity.
The numbers are secret agents now?
What I mean by covert is that the sequence will never reach the next whole number. For example, if I take half of that geometric sequence, I will never reach 0.
Yeah, but the block will be so tiny that it'll practically be 0.
But practically does not mean anything in mathematics. What would you say that the series would equal?
Well, if you started with 2 rows and it kept going in half, then it would have to be 4, right?
I suppose you could call it 4, but in reality it would never reach that whole number. But don't you see that this is a series of infinite geometric series when the rows go covert?
Well, I guess that's all fine and dandy, but I think I'm gonna get out of here now. It's too pixelated for my tastes.
I can see a lost cause when it prevents itself. Maude and I will just go do math elsewhere.
Actually, I'm pretty tired too. I think I'm gonna leave as well.
Well, I never.